Hello, it's great to be here together with you. I'm going to talk about Rollups, MEV, private mempool, and actually you can wonder how MEV is possible on the Rollups that are running on a centralized sequencer where nobody actually can see what's inside a mempool. And I show you different techniques, different MEV strategies that are recently popping up there. I'm going to share with you a part of the research that I was doing as a part of my PhD at University of Zurich. That research was founded by the grant from Flashbot Research. But let's start with, to make sure that everybody's on the same page, what is MEV and what is MEV attack. So it is a very recent example of what happened on Ethereum in March in one of the blocks. So a trader was trying to swap 220,000 USDC on Uniswap v3. And he was simply swapping USDC into USDT. So you'd expect that for 200,000 USDT, you will receive also 200 USDT. However, to a big surprise of that trader, he received only 5,000 USDT. So very simple trade, just a swap one stablecoin into another one, and out of the sudden, most of the money disappeared. And simply, what happened? One of the MEV bot, MEV searcher, noticed such a pending swap in the mempool. Mempool is something like a waiting room for the transactions waiting to be executed. That transaction is present here. So that MEV bot noticed that transaction and bribe block producer, so that two extra transactions were inserted, one before that swap, one after that. So, we say that one was front running, the other was back running, and as a result, simply that MEV bot together with that block builder, they make a profit over 200,000, and at the expense of that trader. This is actually an example of one of the most extreme MEVs. It's a sandwich attack. Generally, MEV stands for the maximal extractable value, and it's about influencing the order of the transactions in a block. Ethereum, but also other blockchains, generally work that way, that it's very well defined how the blocks in the blockchain are being produced. There's the whole consensus mechanisms. However, there are very little rules or no rules regarding the ordering of transactions inside a block. And in case of the Ethereum, actually everybody can see what are the transactions that are in the mempool, that are pending, that are about to be included. And then some searchers, they simply look for the different constructions of transactions inside a block, and they come up with the ideas what to do so that they can extract some extra profit without taking any risk. And there are very different types of MEV. Luckily, most of those MEV transactions, they are actually beneficial for the users. And like arbitrage represents 60% of the MEV. It's about equaling prices, for example, between Uniswap, PancakeSwap, and Binance. Liquidations of the bad debt from the Aave or other lending protocols represents another 30%, and only maybe 10-15% of MEV transactions are those sandwich attacks. However, in case of the Ethereum, they all require that the mempool of the transactions is public. So the question would be, how can we do MEV transactions when actually we do not see what transactions are in the mempool, what transactions are pending, about to be executed? And this is how most of the rollups are operating. Most of the rollups today, I know, CK Sync, Arbitrum, Base, they run on the centralized sequencer. By the way, we can trust that centralized sequencer. But they also have a private mempool. They have a very low gas fees. You can see here that on Ethereum, you need to pay around $5 to do a swap. On those L2s, you just pay a few cents for that. And also rollups have much faster finality. Instead of waiting 12 seconds on Ethereum for your block to be produced, Rollups produce blocks in 200 milliseconds or 1 or 2 seconds at the longest. And actually, on those conditions, they're like perfect conditions for a new MEV strategy. So even if you do not know what transactions are going to be included in the block because they are encrypted, you can make a guess. Because you can see the transactions that were executed so far. And simply by analyzing the patterns that were in the blocks already executed, you can make some predictions. What's going to happen in the next block? And then you can send some swaps inside that block. And based on some based on the statistics, on the probability, some of those trades that you are sending blind, they will be successful. You make profit of them. Some will be unsuccessful, and they will be reverted from the blockchain. However, what is special about L2s, gas fees are so low that even if your transaction is reverted, and you are not successful with your MEV attempt, you pay very little gas fees. This is what you see here, how much you pay on Ethereum and how much you pay on the L2s. And as a result of those conditions, it's still profitable to give it a try and to do that speculative MEV or MEV attacks on the private mempools on Ethereum. And also, what we see is that once there was a big upgrade on Ethereum 1 year ago, it was Denkun that introduced blobs. And as a result, gas fees on Rollups went down significantly. And not surprisingly, after that Denkun upgrade, you can see that the percentage of the reverted transactions actually rose quite significantly, from like 1-2% to 20 or sometimes 40%. So today around 20% of all of the transactions that are on the rollups, they are being reverted. So they are unsuccessful. And most of them actually are those MEV attempts. It's not so actually easy to understand what the reverted transactions are trying to do on the blockchain, because reverted transactions, they do not emit event logs. So if you are analyzing what they are doing, you need to look into the traces, internal transactions, check with which smart contracts they were trying to interact, whether it was some DEX pool or there were some stable coins. And this is what we did in our research. And actually, we saw that majority, like even 80% or on some L2s, 90% of those transactions that are unsuccessful, they are swaps, or they are trying to execute a swap. And what was even more interesting, that from those reverted swaps, more than half, they were trying to do swaps at Uniswap V3, and they were trying to trade only one cryptocurrency pair, USDC and ETH, which is actually providing more evidences than those reverted transactions. They are simply those speculative MEV attempts. And then going further, we also applied some statistical analysis. Maybe today you would say AI, to look for some patterns within those failed transactions on L2s. And we observed a few interesting paradigms. Maybe the most interesting is that a lot of MEV bots actually split trades and they duplicates their trades. So because those gas fees on L2s are so cheap, the block is produced so fast, and you want to make sure that, for example, your arbitrage transaction is executed first. So what you can do, you can simply send your swap maybe 3 times, because maybe one of them will reach the sequencer faster. You can also split your swap into smaller parts. And for example, if you want to do MEV with a transaction of value 1,000, you can send 3 or 4 $300 swaps. And those strategies, actually, they are working very fine where you are trying to do such a revert-based MEV. Then another approach that you can take is to play with the priority fee. So generally on EVM chains, there is something like a priority fee. And every transaction or every user can decide whether his transaction is paying priority fee or not. And the higher the priority fee you pay, then your transaction should be at the beginning of the block. If you don't pay it, it should be at the end. And a lot of chains actually support such a priority fee auctions, but not all of them. For example, Arbitrum and zk-Sync are good examples of L2s that do not support a priority fee. But for the sake of the EVM compatibility, they still accept a priority fee. And what we observe, and was quite surprising, is that even those chains' priority fee doesn't make an impact on where your transaction is in the block. Still, a lot of users pay it, which is simply a wasted money. The rollups are generally working on a revert protection mechanism and on making, influencing or deciding on the order of transactions within a block. And there are two new approaches. At the beginning of this year, in April, Arbitrum introduced so-called time boost. Time boost is a little similar to what Solana is offering at Gito there. And there is something like an express line. So for a time of, for example, 8 blocks ahead or 10 blocks ahead, you can buy a priority line, like the spot at the beginning of the block. And then if you win some auction, then you can decide which transaction you put at the beginning of every block. Then a very different approach is represented by Base and Unichain. They introduced pre-confirmations. They are, I think, the first rollups that introduced pre-confirmations. And generally, the block production on Unichain was rather slow. It was like on OP stack, it was just 2 seconds. And with the flashbots, that every block is divided into 10 pre-confirmations, each produced around every 200 milliseconds. And then within that pre-confirmation, there's also auction with the priority fee. And all those things are important because the faster the blockchain, the less MEV there is. There is less probability that the MEV will be successful, and also it's more difficult to execute a sandwich attack when the blockchain is fast. So maybe going to conclusions. There are different conclusions and takeaways depending who you are. So first of all, if you are a trader and if you are using Uniswap or any other DEX on the blockchain, make sure that you always set a slippage tolerance, because sandwich attacks are very detrimental for the users. As I show you at the beginning, even if you are swapping a stablecoin for a stablecoin, you can lose almost everything. But protecting against those sandwich attacks is extremely simple. You just need to set up a slippage tolerance to 2-5%, and that's all. The important thing is those sandwich attacks can happen also on blockchains, on L2s that are having encrypted mempools. So encrypted mempools actually doesn't mean there is no MEV. The takeaway number 2 is actually for the MEV searchers. If you are doing arbitrage or doing liquidations or Oracle extractable value, you can simply go, and the mempool is private, you can still try to extract MEV that is out there in arbitrage, for example. And you can do that by duplicating your transactions or by splitting your trades into smaller parts. And last but not least, some takeaway for the rollup designers. So generally, reverts, the fact that almost 20% of transactions reverts on rollups is not a bug of any rollup, but it's more a consequence of the design decisions that were taken earlier. And then what rollups can do, and some already experiment with that, like Unichain, for example, is so-called revert protection. And that revert protection will work that way that even if your transaction is reverted, it fails, it's not included in the blockchain state, then you don't have to pay a gas fee. Okay, so I'm coming back to where we started, how you can do the MEV on the fast rollup with private mempool. So generally, it's possible. There is that new strategy of doing MEV there. It's simply MEV based on the reverted failed transactions. So yeah, thank you. And
thank you.
You can follow me on Twitter or LinkedIn, and I will post our full research report in 1 week there.
Amazing. Thank you. Are there any questions? Yeah, there is a question. There you go.
Hey, great talk. So at the end, you mentioned revert protection. So do you mean that it's good to introduce this to a rollup? Because it sounds like if we have revert protection, then these kind of spammers don't pay at all.
Yes, that's actually a very good question about how that revert protection should be designed. So there are maybe two sides of that. One is that every reverted transaction is contributing to the base fee. And when the base fee is going up, it also affects other users of the blockchain. So because 20% of the transactions reverts, it means that other users of the blockchain, they need to pay a higher gas fee. So by getting rid of those reverts, other users will benefit. What actually Rollups could try to do, and actually some are also experimenting with that, is that they will also waive the base fee, but the priority fee will still be charged. So if for example, the reverted transaction is taking part in some auction, yeah, that part will be paid, but the base fee for the benefit of the whole community will be waived.
Amazing. Anything else? No. Thank you so much, Krzysztof.
Thank you.